All right, now that we have a basic understanding of radix sort conceptually, we need to implement a couple of helper methods so that we can actually write the main algorithm. And the first one that we have to do is called getDigit, or something like this, that takes a number and a position and returns the digit at that position. So we might have 1, 2, 3, 4, 5. If we called getDigit 1, 2, 3, 4, 5 with 1 as the position, that should give us this number. So this is the 0 position, the 1, the 2, the 3, the 4. So it's not a string or an array. We start with 0 over here and we move to the right. This is going the other direction. And getDigit is really important for sorting things into these buckets, right? If we have, we're starting the very first pass on this list, we need to take a look at this digit, the 0th digit in our example, and put things in the correct spot. Then the next time through, we need to look at this digit. So we need a method that will give us that digit. And unfortunately, there's no easy way of doing that out of the box. We need to write a method. So if you want to do this on your own, rather than breaking this up into 3 different videos for the 3 methods I'm going to show, I think I'm just going to combine them into one. I know that I'm going to combine them into one. I'm already recording it. The focus is not about this logic. The focus is on the sorting logic of radix sort. But anyway, if you do want to try these, pause the video and do it now. 2 strategies. You can convert to a string and then use the correct index to access the number you want and then convert it back to a number. The only problem is that, as I already mentioned, the strings are indexed from the left side. So if somebody asks for position 0 of this, if you convert to a string and you get 0, well, that's going to be the complete wrong side. So you could do some math so that you can convert, working backwards using negative indices or something like that, then come back to a string. Or you can do some math. So this should only work with base 10 numbers, by the way. You don't have to make it work for binary. We don't need a user. If we were doing other bases, a user could pass in what base, but assume base 10 numbers. So there's some math you can do. Each one of these positions represents a power of 10. This is the 10 to the 0th position, 10 to the 1st, 10 to the 2nd, which the way I learned it in school was not 10 to the 2nd, 10 to the 3rd. It was the ones place, the tens place, the hundreds place. So what you can do is divide by that power of 10 and then do some other math, which I'll show you in just a second to get the answer. Okay, so if you want to implement it on your own, pause it. Otherwise, here's a spoiler. Here's a solution. I just took this from Stack Overflow and it's called getDigit. It satisfies our requirements. Let me show you how it works. Let's say we're taking a look at a number like 73, sure, that number. And if we pass in, so if we did getDigit of that, and I'm looking for whatever number is at this position, 0, 1, 2, so I'd pass in 2. The math is that this number here is 300, right? It's a 3, but in the context of this, it's a 300. So we're going to divide by 100. As you can see here, math.power 10 to the I. So 10 to the 2nd, which is I, gives us 100. So we're going to divide this whole number by 100. So I'll write this out here. We can ignore the math.absolute value just for a second. That's just so that this works with negative numbers. If I passed in a negative number, this should still be 3. We don't want to get negative 3. This is just 3 is the digit we want. So that's what the math.absolute value is. So we'll ignore that. If we take this number and we divide by 100, which is what this is right here, and then we floor it down here, so we get 73.23. If we do a floor, we just get 73. Okay, so then we have 73 mod 10. So we divide 10 into there. How many times does it go in? It doesn't really matter, but it goes in 7 times. So we get 70. What's the remainder? Well, the remainder is 3. So if we do mod 10, we get 3, and that's what we're looking for. So we divide by the place, the hundreds place, then we floor to get rid of that decimal, then we mod 10, and that's the math. So just to prove that it works, run the code, and then let's pass in 0. We get the correct digit, also a 3. 1, we get the 2. 3, we get the 7. And if we pass in something that's not in there, we get 0. Perfect. So this works. We're all good. The next helper we need has to do with figuring out how many digits are in a number. And the reason we need that if we go back here, is in this example, we need to know how many times we need to sort things into buckets. How many times do we have to, reorder everything? And the answer is 4, because the largest number we have has 4 digits. So that's our bound. If we have one 10-digit number in here, then we need to do it 10 times. So we need to write code to figure out how many times we need to run it for a given list of numbers. And all that we need to do is figure out which number has the largest or has the most number of digits. So there's 2 methods we'll write. The first one will give us digit count for a single number. And then the second one will use digit count to figure out the largest number of digits for the entire list. So we'll have, max digits, which calls digit count. So digit count, just you pass in a base 10 number, and it should return to you how many digits are in there. So this would give us 3 digits. This is a 2-digit number. This is a 1-digit number. You could do this as a string, convert it to a string, find the length, or you could do some math, which is what I'm going to do. So pause it if you want to try and implement this on your own. Very loud motorcycle outside. Otherwise, here's the solution. All right, I copied the solution over. It's called digit count, and there's a couple things I'll talk about here. So first things first, log 10. This is log base 10, which what that does, if you didn't watch the log video early on in the course, it's basically asking 10 to what power gives us this number. So if I called digit count on, let's do 423. 10 to what power gives us 423? Well, it's not going to be a nice clean number. So that's why we do the floor. But let's do math.log 10 of 423 gives us this. And when we floor that, we get 2 because we're just getting rid of that. So our answer here was 2. And we're close, except that we need to count the number of digits, which we need to add 1 in, so we get 3. So just one more example, if we have a larger number like this, okay? We're doing math.absolute value again because we want it to work with negative numbers. If somebody passes in negative this number, it still has the same number of digits. We're not going to worry about negative numbers for our sort, but these are from Stack Overflow, and it's always good to be conscientious of that. So if we take this number and we do math.log 10 of that, and then we floor that, we get 4, and we add 1, which is 5. That's how many digits are here. 1, 2, 3, 4, 5. Okay, so if the math is crazy to you, don't worry, it works. And this is something I feel like it's totally normal to just take this from Stack Overflow and add this to your code if you really need it. So digit count, the only special case is if num is 0. So if somebody passes in, well, not there, but if we did this, this is a 1-digit number. But the problem is that if you try and do, math.log 10 of 0, we get negative infinity. That's not what we want. So we have to add this special case in. Okay, that's digit count. And then our last method we need is called most digits. And this will take a list of numbers and just tell us which number has the most digits in it using digit count. I mean, it should use digit count because we just wrote it. I guess you could just do it again. So what I would do is take digit count and run it on each number in this list, and then keep a running tally of what the maximum is, and just return that number. So you don't even have to return which number itself had the most digits, just the count. So for example, in this list, it would return 5 because this is the largest number. It has 5 digits. In this list, it returns 2. All the numbers have 2 digits. So this one's the easiest, I think, because we already have this code if you just want to copy it. The focus, again, is not on actually writing these yourself, but I just want to walk through them. So most digits, here's my solution. It looks like this. I'll copy it over. And it just takes a list of numbers. And we start a max variable, max digits. It starts at 0. And then I loop through nums. And I'm using math.max, which if you're not familiar with, you just pass in 2 numbers. If I do 0 and 12, it's always going to give me the larger number. And so this allows me to, instead of doing like an if statement, if x is larger than my current max, then reassign the current max, I'm just setting max digits to equal the maximum between the current value of max digits and digit count of nums I. So for each number. So if I do most digits of, let's see, 23, okay, of this, at the beginning, max digits will be 0, and then it loops through, and it becomes 2, because the largest number we've seen so far has 2 digits. But then next time through, it's 3. Next time through, it's still 3. Then it's whatever this is, and it stays at that. So let's run this, and I get 8, because this number presumably has 8 digits. It does. I just counted. Yep, 8 digits. Okay, so these are the helpers we need. And now we can actually implement, in the next video, we can implement our Radix sort using these. And the logic isn't that bad once we have these done. We don't have to worry about recursion or any sort of crazy logic. We basically just loop over and split things into buckets and then join them together and do that X number of times, where X is the number with the most digits. Okay, see you then.